All right, now we have question 4. Got A right. Thank the Lord. Pretty much right on this test. Then we have B right here. No response because we got wrong. But the way to do B is to start by integrating. So we have H T equals 8.5 E minus 0.85 T, which was given to us. And I'm going to have to integrate it. That's a dt, by the way. It just looks really, really bad. Then to put it all in perspective, we need to get this number down. So I'm just going to go H T equals 8.5 over negative 0.85 E negative 0.85 dt. Oh, sorry. Plus C. That's a C, trust me on that. Continue down. HT equals negative 10 E 0.85 plus C. Now we need to find C, and you only got height 0. The height is 6 feet tall, so it's going to be 6 equals, bring this down, negative 10 E negative 0.85 plus C. This is what we're doing now. We're putting E to this. This would actually be 0. And then now this becomes 6 equals negative 10 plus C. C is going to be equal to 16. And my final equation for part B would then become HT equals 16 minus 10E negative 0.85 T. And I'm going to put that 16 minus 10E minus 0.85 T. Don't mind, I'm going to erase all of this real quick. Going on to C, no response, not cool. Pretty much put height 2 into the equation. So we're going to put H2 equals 16 minus 10E minus 1.7 and E to the negative 1.7 is approximately equal to 0.1827. So we're going to bring that back down again. H2 equals 16 minus 10 to the, 10 times 0.1827. And that's equal to 16 minus 1.827. And that is equal to 14.17. That means the giraffe is 14.17 feet tall at 2 years old. Gonna erase all of this again. To writing. And now we just gotta work, that was A, B, C. Just gotta work on D, so just don't mind this. We're gonna work on D, which is the pink, because why not? This is what will the giraffe's maximum height be and how long will it grow to? Well, maximum height, put T to infinity on this one. That looks horrible. Oh my goodness. So then that would mean E 0.85 T. That would then become 0. So it's going to be HT equals 16 minus 10 to the 0. That equals 16. And pretty much that just means as time goes on, as time gets very large, the exponential goes to 0. That means the giraffe levels off at 16 feet. Now I'm gonna cut the video and go to the corrected page. All right, it's pretty much another integrating problem. So we have given, this is black. Given is this, and we also have that t equals 0, or sorry, t at 0 sorry, p at 0 is equal to 500,000. So let's put 500. And now it's time to integrate. Let's go to red. Let's do p t equals negative 20.1 e to the negative 0.134 t, 1,000 year per year. That's going to be then 20.1 e, sorry, that over negative 0.134, 0.134 t, then that's going to equal 150 exponential negative 0.134 t plus c. So that's first, I just integrated the first order change. Now use the starting population to find c, and that is 500 equals 150 e minus 0.134 t plus c. But X that out, keep on forgetting, this just means 0. And so now it's 500 equals 150 e to the 0 plus c. And then that equals c equals 350. And now I use the starting population to find c. So I just did. I can now put that equation up into here of p t equals 150 e minus 0.134 t plus 350. There we go. And then, if you don't mind, I am going to erase most of this right here so I have room for B. Let's make B blue. Okay. Same thing as like the other one. So we're going to have pretty much infinite time E 0.134 t. So that's going to be equal to 0. And then that just means p, that's a t, I swear, minus 150 from 0 plus 350. That cancels out. P t equals 350. What this means is that is 350,000 a year. Will be the population after a long time. After a long time. Compared to question 4, this is the same process. Question 4, both problems had to find the just green. You're gonna find the rate of change. Both problems pretty much by integrating, but I'm also gonna find value c, it's 350 right here. And then find the long one, pretty much to set it to 0, just like the giraffe. Now the giraffe was limited at 16 feet after a long time. This was limited to 350,000 feet after a long time. Thank you.